So here we've got interval notation. What is this all about? Well, interval notation means that when you have, for example, a set and you want to write it down, instead of give an inequality notation where it's -3 less than x less than 5, we've got a slightly more elegant way of saying this. So in university, you would probably say something like this. It would be all the x's, which are whole numbers, integers, such that x belongs to the interval -3, 5. So much more elegant. Now let me explain what I've done here. This idea is called interval notation. So bear with me while I remind you of something here. When it comes to inequalities and how we represent them on a number line, remember the solid circle means that we want to include that number, and usually we have like less than or equal to for that particular number, whereas if it's not included, we have a hollow circle there. So that would be just less than 4 in this case. Now, we have a way to do all of this using interval notation, using some brackets and square brackets as well. So let me explain. So here, for example, we have, when you have something like x is less than a, then there's another way of saying this. X is less than a would be x belongs to the set minus infinity all the way up to a. If it's x is less than or equal to a, then we could also say x belongs to the set minus infinity all the way up to a, but a is included, so we put a square bracket there. If this is confusing, I'm sure it will make sense as I progress. If I have x is greater than b, then we will say that x belongs to the set of b going all the way up to plus infinity. So the b is just curved brackets because it's not included. And if I say x is greater than or equal to b, then basically another way of writing that down is x belongs to square bracket b all the way up to plus infinity. Now a few more. If x is between a and b, but a and b are not included, another way you will be seeing this written as will be x belongs to a comma b, but with just curved brackets, not the square brackets. But let's start playing around with the limits now. If a is less than or equal to x and less than b, then this means that x belongs to squared bracket a comma b. If you have a is less than x, less than or equal to b, then it means that now we will have a squared bracket on the right, but a curvy bracket on the left. So x belongs to a comma square bracket b. And then finally, if everything is greater than or equal to or less than or equal to, then we have squared brackets on both sides. So this is pretty much what we would call interval notation, because these are intervals. So basically, this is equivalent to the inequalities. With practice, it will all make better sense. I don't know if you noticed, but the infinities, the minus infinity and the plus infinity, is the idea that if you go all the way to the left, there is this notion of minus infinity. If you carry on going on forever, and on the right is plus infinity. If you keep going this way, it's just plus infinity. But these are not real numbers. We can never say that's included, at least in our level of maths. There is high level maths where you can include that in university, but you'll never see that unless you study maths. So here, the infinities will always be curvy brackets. They're not included in our brackets. So what I'll do is I'll actually upload this on Google Classroom so you have this list and it will all make perfect sense. But let's just move on and just talk about some examples here. So here, firstly, what is the meaning of this interval notation here? And then list the elements of this set, find the number of elements in A. So what do we need to be able to do? Firstly, we need to be able to decode this kind of notation. So here, what does this mean? Firstly, these are all the x's that are elements. Remember, this means is an element of, and remember this z is integers, which means whole numbers, integers, or also whole numbers. So in everyday life, we'd say whole numbers. So now this set A is all the integers, all the whole numbers, which are between 3 and 10, but not including 3, including 10. So that means we will not include 3, but we will start with 4. So 4, 5, 6, 7, 8, 9, 10, like they've already done for us below. So that is because we don't include the 3, because it doesn't have a little line underneath. Now, that is the listing the elements of, and then n of a, remember this n number comes up all the time here in set notation. N of a is just how many numbers do we have in here? 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7. I just have to count them in 7 numbers. So 7. And we are done. So this is like a basic example before we introduce the more advanced interval notation. Now, this, or actually bracket notation, bracket notation would be the notation I was introducing previously. So this is the translation of interval notation. So let me correct that note, actually. This is bracket notation. So bracket notation translates interval notation, which is the one on the left. So this is interval notation here on the left, and once again I will upload this on Classroom. So this is the interval notation on the left, and on the right you have the bracket notation. So the textbook has also done it for us, and it's given us a nice little picture for each of these to explain. Notice he hasn't done the more advanced ones that I did with the infinities. Now, coming back to this, there is a notation here used in the IB, which I am not a big fan of. But, you know, there are 2 notations for this thing. When you don't include b, you can either say this will be squared bracket a comma b curved bracket, or you could have it written this way with the bracket being backwards. So you could put a squared bracket, but the squared bracket pointing the other way. So it's saying that b is not included. Not a huge fan of this, but at this stage, and this textbook really uses it, so be familiar with this, please. This notation here, a is not included and b is included. Basically, this would be a with curved bracket and b with square bracket, but you could also write it down as the squared bracket for a being the other way around. So this curved bracket basically could be written as a squared bracket pointing outwards. A bit strange. And then this a and b not included, normally in a lot of mathematical text, you will see it written this way, so just brackets of a and b, but here you will see it as squared brackets pointing out. So in a way you can remember this. If the squared brackets are pointing towards the number, if they close the interval, then it means that those values are included, so it would be the less than or equal to. And then if it's not included in this context here, we will be swapping the curved brackets, the squared brackets around. And another way would be to use curved brackets. Okay, so hopefully I haven't like super confused you with this notation. I think the best way to make sure we get this and it makes sense for us is to do a bit of practice here with exercise 2E. So I'm going to stop the recording so we can start doing a bit of practice, and obviously I'm going to help you get unstuck if